Something that I learned from this conference this week is that we are in very exciting times to study evolutionary ecology, and in particular because the fast pace of human impacts, I would argue that are driving or affecting not only the planet's biodiversity, but the processes that lead to that biodiversity. And so what I want to convince you today in my talk is that Darwin's finches, who has been a really interesting model system, or very important model system to our understanding of adaptive evolution in nature, is also a very fascinating system to understand human impacts and how humans are driving evolutionary processes in natural populations. And I'm going to start by showing this classic picture of finches. These are ground finches, all black, all males, and the females are brown, so you have a contrast. These individuals were all collected or caught at one site on the island of Santa Cruz, which is the second largest island of archipelago. And there's two things that I find really interesting about these pictures. Number one is that you can see this almost perfect radiation in big sizes and shapes, and those are fairly finely adapted to feed on different seeds with different sizes and hardness. And of course, Darwin realized that, and he actually wrote that it seems like one of these species have been taken and modified for different ends. And then the thing about this, we can actually see how changes in the environment will lead to this tight link between morphological variation and the seed distribution on different sites on the islands. Another interesting thing about this picture is that Darwin's finches and ground fishes in general really represent they are at these initial stages of divergence. In fact, there is quite a bit of gene flow across these species. They actually hybridize. And in fact, when we look at genetic differences across species, we realize that most of the genetic variation flows freely across the genome of the species, except for a few regions that are linked to big size and shape. And of course, we expect the selection is what driving those changes, those variations. And so I would argue that, well, given that we know so much about the system, we can really step beyond and think about how humans are altering this process. And so the way we know about finches and about adaptive evolution in general is that when there is variation in the environment that leads to selection on traits that are associated with fitness, and that might lead to adaptive divergence and perhaps to the formation of new species. And for the case of finches, we know that selection or variation in seed distribution will lead to changes in big morphology, and we can then lead to changes in big morphology that might lead to formation of new species. And we actually have seen this both within and between the species. Here's a bunch of work that we've done on this before, and here we can really see how the adaptive divergence will lead to diversion along the same lines of variation in the food resources. In this case, birds will generally diverge between small and large, adapting to small and large seeds. What they argue is that, well, if humans are really altering the planet and altering natural ecosystems, when we alter these environmental factors, we might be altering the whole process that leads to the formation of these species. And when I tell people that I work in one of the things we do in our lab is to look at human impacts on evolution in general, people generally get shocked because the image or the picture that we have from the Galapagos is this very isolated place, very remote. And people then ask, are there any humans in the Galapagos? And of course, there are a lot of humans in the Galapagos. And if you go to downtown Puerto Vallarta, you will see a lot of restaurants and bars. And it's actually a bustling town. In fact, you can sit down and have Simpson caipirinhas by the side of this fancy hotel, which is called the Finch Hotel, by the way. And not only that, humans are really moving in Galapagos a lot. And this shows the patterns of human population increase in the Galapagos. So they increased from a few hundreds in the 50s to over now 30,000 in the archipelago. And in green, the number of tourists, now we have over 300,000 tourists every year on their islands. So presumably, I would argue that will have important consequences for biodiversity and also for evolutionary processes. And of course, when we move into new areas, we bring in new food resources, like human food resources, and also we bring in all these introduced plant species. And of course, finches will also take advantage of those. And this is a picture I took of this feeder, one home, one house in Puerto Vallarta. And so people really put feeders out there, and then finches will take advantage of them. And we have argued in previous work that the introduction of these food types, including introduced plant species, will actually lead to a weakening of the selection and drive adaptive emergence. In fact, that goes to say that maybe the introduction of human foods is driving the whole, altering the whole adaptive landscapes for finches. And so what we did to study this is we took our binoculars and run around in both Puerto Llora and away from town. And we collected over 2,000 feeding observations to see what finches feed on. And this is one of the results from that study. So this shows variation in feeding preference along a gradient of perturb and the surf side. The black dots represent finch species, and the labels are color-coded by whether those food types are humans in red, human food types, or plant species introduced, or natural food types. And what we can observe here is that finches are downtown Puerto Llora will essentially feed on human foods here in red, things like breads and crackers and pastries. But if you compare that with non-altered site, finches still feed a lot of natural plant species. And I would argue that, well, perhaps this has more important implications not only for the way they feed on different food types, but the way they might share those resources. And so we took a quick look at those index of niche overlap. And then we did this for the two most abundant species, Fuliginosa and Fortis, the small and medium brown finch. And when we did this at the non-disturbed site, we realized that finches share around 25% of the food item of the site. When we contrast that with the human site, out downtown Puerto Llora, we realized the niches actually overlap around almost 100%. So I argue that the introduction of human foods and plant species is really leading to a collapse of the niche differences that we know are the key agent to drive adaptive divergence in these species. And with that, I would say that, well, maybe this has implications that go beyond only feeding on different food types. And for example, the idea here is that at disturbed site, finches won't match their big morphology to the diet anymore. And this is interesting because we know that the whole point, the whole way that finches are diversified is by that tight connection between seed distribution and the environment and mixed morphology. And so I would argue that perhaps in human altered environments, finches are the introduction of human foods are altering the interaction between finch and plant populations. And we're currently doing this by looking at these feeding networks to see how finches interact with different plant species of these different sites. And so this represents at the top different finch species. I will only focus on this Fortis and Fuliginosa, this medium and small round finch. At the bottom, these are different plant species of feeding resources. And we contrast these between the non-urban side and the downtown Puerto Llora. Those lines represent essentially the frequency by which they feed on different plant species or food types. When we contrast with the more urban side, we can see a really striking change. That suggests that finches at the urban side essentially interacting largely with human foods and introduced plant species. And in fact, the natural plant species, in black at the end, it shows that they're essentially being displayed from the main food items species. And again, these networks indicate that perhaps that connection between finch big morphology and the distribution of resources might be affecting larger patterns of evolutionary processes in the Galapagos. And we wanted to look at how this might impact even eco-evolutionary processes. And so, just to go back to this again, what I showed you before is that when there is variation in the seed distribution, that will lead to changes in big morphology. But of course, if we alter the resource base in different places, that will lead to feedback or changes in the seed distribution. And so this is a very exciting field because we can see clearly that there's a strong connection between ecological variation and evolutionary process. And so I argue that by studying how finches interact with different plant species, both urban and non-urban sites, it will give us an idea of how eco-evolutionary processes might be reshaped by the human presence in the Galapagos. And so I would like to go back to this picture of Darwin. And I can think about when Darwin wrote this passage a while ago. And he would have probably never imagined that with the introduced human plant species and different food items, finches might not be really adapting for different seed morphologies, as well as with different food types. So we'd probably argue that perhaps in the future, with the presence of humans, the finch big morphology might be, in fact, adapting for similar aims in this case. Now, I've shown you just a few ways in by which humans can alter finch evolution in general, or finch morphological divergence. But I'm currently collecting data in this new work I'm doing. It's looking at other types of impacts in finches in the lab. And so here's a different set of studies. I've done some work on that. We've done quite a bit with morphology and how the introduction of plant species or human foods might drive changes in morphology. But there are also instances where we know that there is also perhaps cases of extinction in finches, in this case by an introduced parasite. There's a recent study that shows that introduced parasite is modifying the big morphology of finches, and that might have consequences for some times, which might lead to alter sexual selection of these groups. And of course, we know very little about fitness consequences of these changes. In particular, we don't know about fitness and is there adaptive genetic variation related to the change. So currently, we are with a PhD student. We are working on these ideas, trying to figure out whether finches that live in downtown Cordillera, for example, are being selected for these intermediate site genes, essentially, that are linked to the morphology of the sites. So to conclude, I think this is an interesting story because we can use this classic system where we have learned so much about the patterns and the process of driving adaptive divergence in nature, and we can put this into human context and also learn how we are driving this process in the natural world. Thank you.
Are there any cases where, and I'm thinking of finches perhaps with urbanization and human development, especially on Santa Cruz, has led to species which did not, in some sense, naturally occur on Santa Cruz, have now been able to colonize because either abundant food resources or different food resources have allowed another finch species that didn't normally occur there is now occurring in the human habitat?
Yes, that's a kind of very prominent process that has happened in other bird species around the world. In fact, there's a few studies that say that I think 80% of the cities around the world, there's around 2 or 3 bird species are always there. And they're just they call it human spoilers because they actually colonize these environments. And they're able to thrive.